Hello friends. So in the last video we have basically seen the BFS traversal and its implementation. In this video we're going to see the depth first search and its implementation. So basically we are aware that basically there are two important traversal, that is BFS and DFS. So in DFS we go depth wise, like let's say take a simple example here. So I want to perform a DFS traversal on given graph starting from vertex A. So first of all I'll go to vertex A, then I'll go to vertex B which is adjacent to A, then next vertex connected with B is D, so I'll go to D, then next connected with D is H, and let's say I'll go from H to L. Now once I come at L, there are no other vertex which are connected with L, so I'll go back to H, then H has one more vertex remaining K, so I'll take K. Now K doesn't have no other vertex remaining to be traversed, so it will go back to H. Again from H we'll go to D. From D we'll visit G. From G again we'll go to D, and again from D we'll go to B, and from B again we'll go to A, and like that way we'll traverse the graph. So this is basically the basic concept of the depth first search. So let us take one simple example, and from that example we will basically see how basically the DFS traversal works. So we have considered here a very simple graph. Now for each vertex, actually I have given here the numbering 1, 2, 3, 4, 5 like that way, and starting from 0. So basically to perform the DFS traversal, the algorithm basically uses a stack, whereas in BFS we use a queue. So here we have three components: output, one dimensional visited array which will keep track whether a particular vertex we have visited or not, and the stack is there. So we'll start from vertex A and we'll traverse a particular graph. So we'll start now. Now when I start from vertex A, I'll first of all output that vertex, that is I'll print the vertex. I'll mark that vertex as visited, that is 1, and I'll push that vertex onto stack. Now adjacent to vertex A, after visiting A, there are two vertex, vertex B and vertex C. Out of that, let's say I select a vertex B, I'll come across a vertex B from vertex A. Now here vertex B is not visited, so I'll mark this vertex B as visited over here. I'll print the vertex B and I'll push that vertex B onto stack. Now for vertex B, there are next vertex D and E are connected with B. So from B I'll go to vertex D. I'll check whether vertex D is visited or not. So I find that vertex D, which is identified with number 3, it is not visited. So I'll mark that vertex D as visited over here. I'll display vertex D and I'll push that vertex D onto stack. Now once I reach to vertex D, I find there is vertex E and vertex F connected with vertex D. So I'll first of all come to vertex E, then I'll check whether vertex E is visited or not. So vertex E here is marked with the number 4. So vertex E is not visited. So what I'll do, I'll go to vertex E, I'll mark this vertex E as visited, I'll display vertex E and I'll push that vertex E onto stack. Now once I come to vertex E, I find that there is vertex F connected with vertex E. So I'll go to vertex F, and in the previous case we have seen vertex F was not visited. So I'll mark now this F as visited. I'll display F and I'll push that F onto stack. Now I have reached F. I'll find out the adjacent vertex to vertex F. So F has its two adjacent vertex, that is connected vertex, vertex D and vertex E. So let's say if I go to vertex D, I find that vertex D is already visited. So I'll not take vertex D. Then I'll go to next vertex E. So if I check vertex E, it is also visited. So the vertex which are connected with F, that means all vertex connected with F, all those vertex are visited. So at this point of time, I will pop vertex F from stack. So I have popped vertex F from stack, and then on the top of stack the next vertex is E. So for vertex E, I'll find there is vertex C is connected with E. So here in visited array, I will check whether the C is been visited or not. So here vertex C is not visited. So I will mark vertex C as visited. I will visit that vertex C. I'll display vertex C and I will push that vertex C onto top of stack. Now once I reach to vertex C, the vertex A, B and E, they are connected with C. Now here this E, B and A which are connected with C, they have been already visited and they are marked here as 1. So at this point of time, I will pop C from stack. Now at the top of stack there is E. So the vertex connected with E are F, D, C and B. But all these vertex they have been marked as visited and we already consider those vertex. So again we will pop vertex E. Then on the top of stack there is vertex D. So for vertex D, E, F and B, these are the vertex connected with vertex D. And all those vertex marked as visited. So vertex D also will pop from stack. Similarly for vertex B also, all the vertex connected with vertex B we have already visited. So we will pop vertex B from stack. For vertex A, the connected vertex for vertex A all we have visited. So we'll pop the vertex A. And ultimately our stack becomes empty and we'll get the final output as A, B, D, E, F, C. Now let us try to let us try to summarize the steps for DFS traversal. So first of all, we are considering a single vertex. We are pushing that vertex onto stack. We are printing that vertex and marking that vertex as visited. Then we will find out adjacent vertex of that particular vertex, provided that vertex is not visited. We'll push that vertex onto stack. We will mark that vertex as visited and we'll display that vertex. So subsequently, we'll visit all the remaining vertex provided that they are not visited, pushing onto stack and displaying those vertex. So we will keep traversing and keep displaying till our stack is not going to be empty. Now let us see the implementation of a DFS. So in DFS basically we have seen using adjacency matrix and adjacency list. So adjacency matrix is quite similar for both BFS and DFS, but instead of having a queue as we have seen in BFS, in DFS we are going to use a stack. So already the creation of adjacency list and all those things we have seen in our previous video. So this video will basically see the DFS algorithm. So here this is the DFS implementation using adjacency list. We are passing here one structure pointer array and the number of vertex in given graph. We are taking one reference pointer, structure node pointer P, visited array, one dimension array and two variables V and F. First of all, we will initialize our array to 0. Then we will select the first start vertex. We'll mark that start vertex as visited, which is 1. We'll print that start vertex and we'll push that start vertex onto stack. This was now initial condition. Then here we are using a do while loop. So we keep processing till our stack is not going to be empty. So first of all, we'll take the first adjacent vertex to vertex V, and that node I'll pointed through P. So I'll keep on traversing till P is not null. So I'll select that P of vertex, and if that vertex is not visited, I'll mark them as visited. I'll display that vertex and I'll push that vertex onto top of stack. Then I'll mark that vertex as a current vertex V. Then again I'll continue further. So if let's say that particular vertex is visited, I'll find out the next adjacent vertex of particular vertex V. So through P I'll traverse to the next adjacent node. Now after this, let's say I have completed a particular vertex V ka all connected nodes. So at this point of time, that particular P will reach to null. So that means on the top of stack, whichever the vertex is there, we already consider all the connected vertex of that particular vertex. So we'll pop that particular vertex from the top of stack, and if stack is not empty, we'll take out the next vertex from top of stack and find out its next adjacent vertex, and we will continue the same process till our stack is not going to empty. So this is basically the implementation of a DFS traversal. So we revise once again what we have just seen in the particular video. So we have seen in graph traversal there are two types, DFS and BFS traversal. So in this video we have just seen a DFS traversal. We go depth-wise where we check out the connectivity of particular vertex with its adjacent vertex. Then we have considered a simple example, and in that we basically consider three things: stack, a visited array, and the output over here. So stack is basically to considering the node and performing a backtracking. Then visited is to keep track whether the vertex which we are going to consider is visited in past or is not considered. So we are going to consider it now. And output is basically to display the particular traversal. Then we have seen how basically we visited all those vertex one by one by considering the content of the stack and its visited status. Then we switch to the C implementation of DFS, where we consider here adjacency list as a graph representation format, and based on that we have basically traverse for a DFS. So the next video will start with minimum spanning tree. Before that we will consider the comparison between BFS and DFS traversal and the time complexity for adjacency list and adjacency matrix implementation. So thank you so much for watching.